All right. I think we can get started now. So a lot of people have actually joined it today. So welcome to Office Hours, guys, and it's nice to see a lot of you actually come to office. Thank you so much for taking the time to do that. Besides that, today's special. I think we've been doing Office Hours for a long time now, and this is our 12th edition. And as you all know, the whole world is talking about what's happening in AI, and everybody's building a lot of tools. Everybody's vibe coding. Everybody's writing modules and trying to incorporate AI into different parts, into different areas in their workflows. So that's what today is about. As we have been, the team has been hard at work at trying to figure out how we can use AI to make platform engineers, DevOps workflows, all their lives better. And that's what today is going to be about. Usually we have like a bunch of features that we have launched, but this is what we've been hard at work over the last few weeks. And we have Rohit here who will give you a live demo of how you can use the MCP server that Facets has built and what workflows you can use it for in your daily lives. So yeah, without further ado, over to you, Rohit.
Hey, hi everyone. First of all, thank you everyone for joining for this office hour session, especially the Capital folks who are in office with us. Um, yeah. So to the agenda for today, we wanted to demonstrate the Facets Terraform module generation at MCP to you guys. So just to recap a little bit, so a while back, we had introduced the feature of inner sourcing where as Facets customers, you guys can write your own modules and extend the platform, right? Like you don't have to wait for our team to give you any reference implementations. Instead, you can write things on your own. So that was a capability that was built around the idea of design by contract, where we have an extensive guide on how to do it. So it's essentially Terraform module, but with certain contracts on what are the input types, what are the output types, and what module takes what inputs, and what are the dependencies, things like that. You can define in a declarative fashion. So this is a very powerful thing for platform engineers, especially like if you want to, actually uh, inculcate the culture of developer service, while you guys focus on building capabilities. So this is called inner sourcing capability. Like you have the documentation in readmefetches.cloud where you can learn how to do it all by yourself, right? So now what we're introducing is the MCP server, which you can couple with the LLM of your choice, and you can get AI agents understand that have the knowledge of how to develop these contract-driven modules, and that will accelerate your ability to add capabilities for your developers to use. So that's what we'll see today. Um, so you have the module writing documentation here in case you want to check out, and there is a, in all the control planes, you should be able to see an op center where there is a module registry where you can see and download the modules that are there and also publish your own, right? And that whole workflow. And without ado, I'll jump directly into the MCP part. So there's this repository. You can put the link on the chat one. So you can all get the Facets module MCP server by just pasting this particular JSON block onto your MCP server configuration wherever you use it. So in my case, so I have Claude desktop running, and in my developer configurations, I can just paste that block, and I'm good to go, right? So only two things that you need to configure are your credentials, basically your control plane URL, what Facets control plane are you used to, what is your username and your token, or you can do an Facets FTF login and then select the profile that you have been using, right? So that is how you can configure the module itself. And also you could configure a directory, a working directory where all of your modules should go in, so that the MCP, you have the guarantees that AI is not making some changes to some other files in your system, right? So you configure a working directory, and that's where all of the modules will get generated, right? So I have it set to office hours modules right here. Let me just open up Claude again. And first, so the objective of today's session, what I have it as, is to generate modules with which a developer can set up an ECS based environment end to end automatically, right? Like which is Amazon's Elastic Container Service. So we'll create an ECS cluster, we'll deploy services into it. So all of the modules for it we'll build from scratch. Yeah. So to start off with, there is a module that I've already created for ahead of time. So which is the Office Hours, the VPC module, right? So for an ECS cluster, so let's just recap how the whole architecture would look like. There would be a VPC, there would be an ECS cluster, and ECS services would be bound to certain subnets, like private subnets within your VPC. And then if you need, you can have a load balancer that is sitting in the public subnets and routing traffic over to the ECS services. So I'll just walk you through how this module came out to be. Right? So I just open up my Claude. I have my Facets modules MCP already running. So I can see all of the tools that are there. Like there are a bunch of tools that are needed for. That is bundled with the MCP server. So those you can view here. All of those are to be enabled. And then I go ahead and say that, hey, I want to create an AWS VPC module. And then I start describing the nature of it. Right? I say that it should automatically span across 3 zones in the current region. It should create private subnets 4,000 IPs each and public subnets with 512 IPs each, and one in each zone, right? And then I say that automatically compute the subnet siders because I don't want my developers to be inputting siders, wrong siders, or whatever. So automatically compute the subnet siders based on the VPC CIDR that is provided. I also instructed to use a common NAT gateway by default and provide an option to have a gateway in each zone, right? And then I say that, okay, since this is specifically for this demo, I told that let me make the flavor of the module Office Hours. And then prefix all of the output names with output/office hours, just so that we can easily distinguish them. So now that's it. What the MCP, the LLM with the help of the MCP, it first goes and reads the instructions that are there. So this is the first tool out that is there, which tells the LLM the concepts of what a Facets module is, what it should do, and all of that. It read all of that stuff. It went searching for any modules that already exist, so that if it needs to work with or mutate one of the existing modules, so it went ahead and checked all of that stuff, and then. Next is that it needs an AWS provider to work with clearly. So it needs to find out what provider it can use to, what module it can provide the provider to it. So it searched for HashiCorp/AWS and then found out that there is a particular output that provides that particular provider called AWS account details, right? So it found the output that it needs to use while configuring the provider itself. And then I had instructed it to design the module first. So before jumping ahead to the implementation, just like we would do, we would need to sit down and decide what are the configurability that we want to provide to the developer and what are the logistics of it, right? So this is where it came up with a plan. It said that it will create the intent VPC, it will create a flavor called Office Hours, it will support only the AWS cloud, describe the purpose, and also gave us the overall structure of it. So it will create VPC via using the user provided CIDR range. Then it will automatically select the 3 AZs, private subnets as we instructed, public subnets as we instructed, NAT gateways, internet gateways. So I didn't even mention about internet gateway, right? It just figured out that, public subnet, so it would need an internet gateway. And then it identified that there is an input requirement of having AWS cloud details so that it can configure the provider. And it suggested me to have outputs, one called Office Hours VPC, and then have one for network config, private subnets, and public subnets, like have 4 different outputs. And then some implementation details as to how it would do it. So it will use a data block to identify the availability zones and then pick 3 out of it. And then smart CIDR allocation, how it would implement. All of these things it summarized to me. Now, I suggested that I would want to keep only one output for simplicity. I don't want four different outputs, just have a single output and bundle all of the VPC related details. Your other modules that you plan to create would need the private subnet IDs, public subnet IDs. So include them in an object called attributes, and that's how the output should be structured. So it understood those requirements and then suggested me this is how the output would look like, and then registered the output type for me. So it has created. So it first defined the contract, much like in programming. How first we decided what I mean in this particular case, it has first decided what is the type that it needs to output. What is the return type here, right? And it has registered it so that it is now made available in the control plane for other modules, other MCP servers, other developers to know and use those. Now it suggested that, hey, shall I go ahead and start off with the implementation of the module? I say yes, and then it does its job. So basically, list the files, create modules, and write config files. Right? So it has created these one files, and then said that, hey, I'll have these as the inputs: VPC CADR, NAT strategy. So that is whether it is going to be a single NAT gateway or a per zone NAT gateway, and then enable or disable the DNS host names and the DNS support. So I said that I do not want those extra configurability, just keep it on by default. I want to keep it as simple as possible. It went ahead and made those changes. So it's now very limited, which is VPC CIDR and NAT strategy. And then there is a dependency on AWS account. All of this looks good. So I said, it prompted me whether if it wants to go ahead and write these configuration changes. Yes, right? So this is where it goes ahead and actually writes all of these things into a module inside my in my folder. So let me just see if I can. Yeah. So it has created this VPC directory, and within it. Yeah. So within it, it has created a folder for the particular flavor and the version, that is a 1.0 version. It has created a Facets YAML, wherein it has created an extensive Facets YAML where it describes each field, what is it for, and when to use it, and also defines the outputs and the inputs that it would take. So this is all things that you would learn by going and reading the documentation. It has the inherent knowledge of it, and so basically it has created your module's interface with the developer and the basic dependencies that it has, and define the output of it. And then it goes up. The next thing it does is goes and based on the input structure, it goes and generates a variables file. So it goes and generates a variable file because it knows the input structure, what are the validation conditions. So in fact, it has put a condition even at the Terraform level that the CADR has to be valid. It has put a validation that the enum, although there is no actual enum support in Terraform, so it has gone ahead and taken it as a string, but implemented the validation on top of it. And also, even for the inputs, it has added this schema for it. Now, based on these variable definitions, you know that any LLM that you use, once you define the contract of what is the output, what is the input, it's the cakewalk for an LLM to actually go and implement it, right? So it has created this vpc.tf file where it is creating the VPC, the internet gateway, the subnets as required, and both the public and private subnets as required, configured the NAT gateway, along with an EIP, and there is a routes file where it has configured the routes for the public and the private subnets as we requested it to. So going back to Claude, so this is where it did all of its development. It summarized whatever it did to me, right? So it has created this module structure. It summarized to me. Now it suggested me, do you want to have any additional configuration or preview this module on the Facets control plane? So I say I am good with whatever is my variable configuration. Go ahead and preview it in the control plane. So it actually pushed the module onto the control plane. So I was working on this control plane in the module registry custom modules. If I search by this office hours, so this is a module that it registered, it pushed it, right? So it indicates it by saying that it came from the source, that is AI. Now, once it is pushed, what I do is that I have a test project. So Let me just go here. So I have a test project in my control plane called Office Hours. I just searched for the VPC module over here and selected the Office Hours flavors and added it to the blueprint, right? I added it and gave it a basic configuration. So while configuring it, I noticed that I mean, yeah, now it is all sorted. But when I configure it, at that time, it was asking for VPC Cider over here as a field. So I said that VPC Cider is going to be different for each environment. So it cannot be in the blueprint. You can't hard code it in the blueprint. So this is when it realized that, hey, I need to make it an override only field. It made the appropriate changes. And now if you see, there is no cider part here, but when you launch, it automatically prompts for the cider, or in the resource center, you can go ahead and configure the cider, right? So if I go to the resource center and configure the resource, I have the cider option coming over here, and I've filled up whatever I wanted to use. Once I just did that, I did not go ahead and do a release or anything, and then it suggested, yeah. So it confirmed with me whether it wanted to do the update. It did the updates and again published the updated module onto the control plane. So all of this while all I'm doing is starting with Claude and just going and looking looking at my blueprint, right? And then it suggested to me, now do you want to test your module? So I say yes. So it went ahead and listed down all the test projects. These are the test projects that are available. Which ones would you want to use? And I made my choice that, hey, go test it out in the Office Hours project. So what it did now is it triggered a release, right? So in this particular step, it actually triggered a release. So it actually triggered a selective release of the VPC itself, right? So this particular release was done by the AI, and it waited for the release to complete. If there in this particular case there was no errors, but in case if there was an errors, it would go back, fix the code up, and then publish it again, right? So this is this whole chat shows how in a matter of minutes we could have a VPC module that was ready to use and we'll be able to distribute it from our control plane to the developers to go and use it themselves. So now what we'll do is try and do this live. So what we'll try and do now is create the ECS cluster module that we want to. Any questions so far, maybe from the room in the chat? So in that case, let's go ahead and create a module for the ECS cluster. So I'll suggest that use Fargate or Fargate Spot or mixed only, not the EC2 instance option. So let's allow Fargate Spot. Well, not have too many fields in here other than choosing whether it is Fargate or Fargate Spot, right? I'll also add this instruction saying that use the flavor Office Hours and prefix all output with Office Hours. So let's see what it does right now. So it's reading the instructions right now, and then coming up with the structure for the ECS module. So it's saying that it will use the intent ECS cluster flavor Office Hours. So it will support Fargate Spot, and mix of both. And the module will have only essential configurations. Yes. So far, it would not have created anything over here. It's not done any write operations. It's just confirming the design with us. So all of these, while it is doing, at each point there are a lot of safeguards. Say, for example, it generates a schema and then the variables do not adhere to it. There is a deterministic check over there to make it course correct. It will throw an exception. The tool will throw an exception. So the LLM would come back, correct its mistake, and then proceed. So this applies in verifying that the spec schema matches the variables, or the outputs that you have generated matches the output that was designed and registered. All of those checks are baked in. Yeah. So it uses our FTF CLI to generate the module scaffolding first, and then goes ahead and reads the file. So right now I should see a basic skeleton right now. It has got nothing, but it will work on these files to generate the module. So it is creating ECS cluster attributes. So if you see here, it has designed the output. So where it is adding cluster ID and cluster ARN and the cluster name as attributes into the output type. Now it starts writing the Facets YAML itself. Yeah. So if you see here, the facets.yaml is still the bare bones that was created initially using the CLI, but it is asking me to review if this is okay. So it would provide a capacity provider strategy where it is Fargate only, Spot only, or mixed. And then it has added a field called enable container insights, and it would take the AWS account as the input, and that's it. So for an ECS cluster, you don't need anything else. You can just create. When you create the ECS services, when you would need VPC outputs and things like that. Yeah. So this looks good to me. I'll say yes. So now it would run the same tool, but with dry run false, which would mean that it can actually write files into write into actual files. So again, so it updated the Facets YAML first, updated that these extra fields would be there. Based on that, it updated the variables.tf file to match the schema, and then goes ahead and writes the. Yeah. So if you see here, it is also environment aware, right? So your module is automatically generating names based on environment and instance name, so that this module is generic enough to be used in any project anywhere. So the onus on making sure the names are unique is not on the mod who is invoking the module, right? It is automatically unique. So it is done with all the coding it has to, and it is now performing a validate module function, and it will give us a summary. So just going back, so there is this ECS cluster. Something is So ECS cluster module where it has created the cluster.tf file. Again, so it has a setting for container insights, and there would be the cluster capacity provider based on the strategy that we have provided. So it will take weight and whatever is the capacity. I mean the spot. I mean whether we want to use Fargate or Fargate Spot. Right. So it has summarized that it has done everything. So yeah. So let's review. So it will now publish the module onto the control plane as a preview module for you guys to use. So let's just go to module registry. Yeah, so the ECS cluster module has gotten registered a minute ago. So now I'll go back to my test blueprint, and I can add it. So ECS cluster office hours, my clusters. Right. Yeah. So let me add it to the blueprint. And I can say test the module. So we'll find out what are the test projects that are available. Yeah, so it says it has triggered a release. So now it has done a selective release specifically for that particular resource. So it will verify that it is going through. If not, it is capable enough to look at the logs and fix it for you. So it is keeping on checking the deployment status over here. It's just polling for the release to complete. Yeah, at least it is getting created. Yeah, the release something. At least the ECS cluster is created over here. That module works. Let's figure out what I mean. That will keep aside. Let's move on a little bit and look at the ECS service as well. Now we'll go back to the other module and just give it the output might be office hours VPC. So I'll suggest that get the VPC details from this output. and the cluster details from the ECS cluster output. I'll suggest to have assume it is a single container. Yeah, so it is going and reading the existing output types that are there so that it can know what inputs it will take, right? And so it has done so for both of the outputs. So one is the ECS cluster and the VPC. And the module will be generated with the following configuration. So intent is ECS service, flavor is office hours, cloud is AWS, and he'll take these two details from these inputs and supports single container deployment, image port, environment variables, HTTP load balancer optionally. Looks good. Yeah. So at this point now, it is again doing all of the work that we had said, right? Like of generating the spec, and then it will confirm with me whether it is good to go, and then obviously Terraform code itself. It found some mistake in the Facets YAML, and it is course correcting itself automatically. Yeah. It is also creating an output type for the service module and registering it with the controller plane. So this is the beauty of it. So this particular module understands that there is this VPC module that offers certain output, and there is a cluster module that exposes certain output. So it is able to write code that just plugs in with both of the modules very well, right? So you don't, so that for the dev end user, it's super easy to consume. Similarly, like this whole workflow could unlock you in quickly automating anything that needs orchestration. It need not even be cloud related. We have some of our customers who have been using this for their data pipeline orchestration. You can use it to generate, GitHub repositories, Bootstrap the GitHub repositories, maybe even Bootstrap AWS accounts, things like that. So now anything that you can do via APIs and coordinate, you can do so using modules as well. Yeah. So it seems to have generated the ECS service module as well. Let's see if it's good to go. Yeah, it was waiting for my confirmation to actually write the code. So it'll write the code, validate, and then proceed. So during the validate step, it'll definitely do a Terraform validate to make sure that there are no basic syntax errors or anything in that it has made a mistake on. And then also Checkov scans can be run there. So essentially, it can catch any of the policy violations that we have configured on Checkov. It'll invoke Checkov and do a static analysis of the Terraform code that is generated. It also generates a README file. So maybe we can just go back to some of the modules that we registered. So in the VPC modules, if you click on it, you'll get a nice little README explaining what the module does and how it is to be used. And the same you could see in the Blueprint Designer when you're working with the Blueprint resource itself. Yeah, so some of the other things that you guys can do now is you can go to any module that is already available. Either go download the source if it is your own custom module, right? Like if it's a custom module like this, you can download the source from over here. You can bring it to your MCP and then refactor it and work on that. We would prefer for you guys to have a Git repository where you commit and use that workflow to coordinate. But this is easy way to quickly prototype in any new modules. And even for system modules, we are most of the modules right now go into a public repository. So you can fork our modules from over there and modify it using the MCP and use it yourself to customize it. Yeah. So the ECS module is now validated and pushed to the control plane. Let me just go and create one. So now when I add the ECS service, it is asking me to select which VPC and which ECS cluster it needs to deploy on. Right. So let me just add a hello ECS service. I can go configure it. Yeah. So I'll enable it. Yeah, so it is asking me the name. So I think probably I should say that name should be generated. So I can ask it to correct it. And meanwhile, it is now one cool thing here is it is automatically understood that this is of a type service or an application that you would want to deploy. So it has automatically integrated artifacts to it. So now you get a UI from where you can set the image for it from your repository or wherever, right? Um, yeah. So let me just wait for this to continue. Yeah. Meanwhile, let's review the other fields over there. So it asks for the image, container port. Yeah, CPU units is nicely put up as a drop down, so that because in ECS only certain values are available, and then the environment variables it is provided as a text box. So environment variable should be a YAML box, right? So we could ask it to do that as well. So I can just say environment variable should be YAML editor, and it will go configure that. So it has made the corrections for the service name. So you don't need to worry about that. And we'll let it make it a YAML editor as well. Anyway, so in our vision for the four-fold Facets Intelligence suite, MCP servers are the first step. So that we have a way for LLMs to interact with our product, our platform, and then we want to slowly progress towards purpose-driven AI agents that makes the usage of the platform easy, maybe even something that is developer oriented, and they could suggest that, hey, I want to add certain dependency to my application, and they don't even have to come to the blueprint or override stage, and they'll be able to do it with natural language, right? And we want to do this, tailored for different project types as well, so that for ECS, for Kubernetes, it could be different agents that can be very context aware and do that same. It's a slightly downside. Let's go. Should be done now. So once it updated the YAML block, it is also making sure that it is being read as an object in the variables, and it will correct everything. Yeah. Meanwhile, anyways, I don't plan on adding any environment variables over here right now. Um, Let me just recreate it just to verify that it's no longer asking for the name. So ECS service office hours, hello, add. I think it would not have previewed it. Yeah. Meanwhile, if there are any questions, you guys can put it on the chat so that we can address it towards the end of the talk. We should be winding this up in a couple of minutes. Yeah, so it is now pushing the preview module. Right. This configure it. Okay, it's sorry. Let's just create this and test this out. So I'll just name it hello. Everything else is fine. Um, and I'll just enable the load balancer itself. Let me save it. Raise the ECS servers. Yeah. So Surya is asking, does it have a capability to update the files in GitLab instead of local files? And we use this Terraform MCP server with so it can work with, it can commit into any VCS repository as you need. There is no limitation on that. The client with which you use it should not be a problem. It should work with any LLM client that supports MCPs.
The next is where the MCP server is running.
Yeah, so the current MCP server is currently running on your local. It would run on your laptop. So maybe in the future when the remote MCPs become prevalent, this can switch to that sort of a mode as well.
This question is
how any junior developer can benefit from this? Can you explain some use cases for any developer? I would suggest that this MCP is more oriented towards a platform engineer, and even if he's a junior platform engineer, he can write down his requirements in natural language and get a functional module. That is the gain that he can get out of it. And then from a consumption point, any junior engineer who needs to add a dependency for a service or add an ECS service and configure it, add a new microservice or something. The platform provides the advantage that you can just go to the blueprint designer and add an ECS service all by yourself.
We need to clone the repo to use this.
No, you need not clone the repo. It is published in the Python registry. So all you need to do is run it. I mean, so without cloning, also you can run. So Facets module MCP at the version that you want, or you can just leave it without the version. It will pick the latest version and run it. You don't need to clone the repo each time. All right. So thanks everyone. Thanks for your time. I hope you guys can all test this out and give us some feedback. I hope it makes your life much easier.